Can anyone start the system here?
You were living in maybe on Wednesday in the evening.
Okay, so please take your seats. We are ready to start the session. I hope that the air meet is working. Yeah, we are starting. Is it okay with the air meet? Can anyone confirm that it's working? Okay, I think it is working. It's not in, but it's not shown in the presentation mode on the web. Can anyone from the local organization help maybe with this? Because people, I think that they see a small platform. Maybe you have to stop and then start again. Sharing the wrong. Thank you to sharing again. Okay, now it's great, thank you. Okay, so let's start again. So now we have Elahe Maleki presenting multi-perspective approach to integrate domain-specific semantic into the system model. Thank you.
Good afternoon. We worked on this project with my colleague Jean-Louis Trayon, Albert Gonzalez Fernandez, Kirin Vinance, and Ilaria Roba. So I should not go there. So we just go short introduction about who we are and what is the digitalization project in ESA, and the project focusing on ontology at ESA, and then what is our problem and the case. So we talk about the idea how to overcome our problem and what we did to fulfill those needs. Then we talk about a bit the framework we are proposing and one use case that I can explain the model based on that. And at the end, I just conclusion. So first of all, who we are. We work at the European Space Agency in the European Space Research and Technology Center. We are in the system engineering division, who is responsible for model-based system engineering and in the project and disciplines overall ESA brands. So the origin of the whole stuff when we talk about ESA Agenda 2025, it will continue 23 and 30 and all around. It's about digitalization, which talks about digitalizing all projects in all disciplines through the life cycle of space project by applying model-based system engineering, and which will somehow is the basic for digital twin. So, but we don't say digital twin there, we say digital spacecraft. So when we talk about digital spacecraft, is exact digital twin, we want our own words. Digital spacecraft is this the idea of having a digital twin of the space project from the preliminary phases until the operation of the space systems. So in doing that, we have some sort of what we call MBSE hub. We start working on this objective in our team by creating the MBSE hub, which has the MBSE for all disciplines for all projects. So the idea is to having digital continuity between projects and between disciplines, between projects, and between all stakeholders through the life cycle. In doing so, we need two basics, which are standardization and interoperability. So standardization, which is called ECSS in ESA, it's the European Corporation for Space Standardization, and OSMOSI, which is Overall Semantic Modeling for System Engineering. OSMOSI and the ECSS are always in doing exchange because OSMOSI tries to capture all semantics from different standards, from ECSS, which is our reference, and also to create a top-level ontology. So they create a top-level ontology, which is called SSO, Space System Ontology, and then domain ontologies that are attached to this top-level ontology. So we call them, these domain ontologies, we call them Universe of Discourse, or UOD. And we'll explain how we go from there to ontology. So let's focus a bit about on the MBSE hub. The discipline we work is system engineering. We have some sort of new way of working, which is concurrent design facility, CDF. CDF is actually basically exactly, this is a photo from one word, is that people from different disciplines sit together in a room and they design the primary, do mostly feasibility studies for space projects. And they are connected to one tool, which is called OCDT, Open Concurrent Open CDF, actually. So this MBSE hub is in the core with that OCD tool, which are every domain, every engineering domain are connected to that OCDT, which they have their own simulation or software, whatever, and they can do real-time design validation. For example, if you have some data from thermal engineering changing some parameters, it can, in real time, it will show the effects of that parameter changes in structure or other engineering. So to do that, of course, we need ontology. OSMOSI is created to answer this need. OSMOSI is the top, as I explained, is a top-level ontology plus model domain ontologies. So OSMOSI is mostly focusing on that because we have different primes, different companies working together, and space systems are considered like complex systems. We say that they all have their own data repositories. They create their data from like physical data, logical, and conceptual. OSMOSI is focusing on the conceptual level to have the interoperability between primes, Airbus, ESA, and Thales, or other partners. So, okay, so till now it seems everything good, except that we have a problem. In every disciplines, we have like many disciplines, and I put some example like this just. They have their own viewpoint on spacecraft or a space project. One simple example I put here is that we have one satellite, we have solar array. We consider it as some simple concept, except that solar array has different viewpoint from structure. The view from structure and thermal engineer are not the same. but they have exchange, and they are connected. So what we talk about, which is captured from the engineering domain, is that they have requirements towards each other. So this, when we do the ESA top level ontology, is mostly system engineering concept, which are the core concepts. But when we do the MBSE and modeling of each discipline, they have only their own view on the spacecraft. So we miss some interfaces, and then integration of this discipline to the SSO and also the digital continuity view, when we were talking about, is will have problem. So what we did, we said that we adapt this concept of perspective from engineering domains, because in ECSS, when you talk, every discipline say that, okay, I have my own requirement. So we took this perspective. We said that, okay, we have some, we call every discipline that we are trying to model it, we call it our system of interest. So we create an ontology with all our requirement or data exchange with other disciplines. So it's going to be a modular ontology with a multi-viewpoint approach. In doing so, we start to extract the domain knowledge. We have our domain experts, engineers in each discipline. This is a process we do for each discipline. So we have design process, we have ESA taxonomies or creating ontologies we hope for, and of course ECSS standard as our main reference. Then we start to define our concept, and then we go for the first validation, mostly not in ontology tools. And then we go to translate them into the ontology tools. And then again, this process is going, circling between going forward and backward to validate the ontology. So for each discipline, we have this, and again, we have that multi-perspective, like, which consider different disciplines together. So that there are always exchange between this and the topper when we want to create the whole framework or something like that we can call. As you can see here, what did I do? Okay, we have experts everywhere. We have all-time discussion with expert domains, with our good friend Airbus, with different software engineers. But so discussion is at the core of our the process. For that reason, we said that we choose normal ORM. Normal ORM is really strong in verbalization. So when you are working with non-ontology people, not people who are not expert in ontology or software, it can be easy to understand them. For them, it's easy to understand the concept and to solve the problems. So we consider it in such a huge project, huge complex projects, it is useful. One example of the way I think, I don't know how you are familiar with that or no, I just explained that system of interest has requirements towards external society, start to verbalize everything. And I can populate concepts that I want. So if my system of interest in that case is a space segment, we can populate them and we have all semantics saved and verbalized. So we validate every pair of concepts. We call them ORM is object role modeling. So for example, system of interest is our object which has a role or pair of roles, we call it factoid. So we validate one by one and we go through the building of the model. So as you can see, it's really flexible. It's not well organized because we cannot close the doors to say that, okay, this is the final concept. So we go through this for a long time to validate the final concept we want. This is the first version we proposed. Actually, since I proposed this one until now, we have some change. So, but now I will talk about the first suggestion, and then we'll see. So, as I explained, every item in our spacecraft is defined by perspective So we can say perspective of your system of interest, the one that is important now for you, and the external system. This external system and system of interest has, as I explained, requirements towards each other, which are defined by the engineering process. Sorry. And I did not focus that much on all concepts because, for example, parameters are something like really defined. We are not going to define parameters. These are like from engineering software. So we just use whatever thermal engineer or software or power supply engineer using their software, and we take that parameters and use it here. So we are not designing that much, but the most important thing are that the concepts of that each item should be defined from two different perspectives. So when we go through these disciplines and with this approach, at the end, we will not lose that digital continuity. One example, this is a project that we're using ESA to, it is some sort of simulated project. It is some Earth observation project based to collect environment data. For example, in this case, is ocean data for climate change. So we can say that, okay, our project, when we say mission or space mission or space system is the same for us. Okay, for each mission, we have that, we have one system of interest, of course, based on sim engineering, which is our space segment, and then different external system. For like space segment has exchange with ground segment, launcher, Earth or ocean as the environment, and customer. For this presentation, I'm going to just give you one example, simple example from the exchange between ground segment and space segment. So you can see how we can use that in our model. So this is the satellite. So we can say that, okay, this is our space segment, which has exchange with ground segment. What I'm choosing as the process is like solar array deployment. When you send the satellite to the orbit, it takes few seconds to unfold these solar arrays. So the data, which data is important for this solar array, because these kind of satellites are working, they gain their energy from these solar arrays. So we check all time what is the rotation per day and what is dynamic validation. The rotation per day is something coming from that spacecraft or satellite, whatever we call, and the solar array dynamics coming on the contrary from the ground segment. But they are both focusing on one item, which is in, if we categorize them, it is in a space segment. So we have exchange with some external, which are like critical data from them. So as you can, here we can see that this one, the satellite itself or our system of interest provides data from rotation per day. And our external system is providing information about dynamic validation, solar array dynamic validation. So it sends command and control to the satellite, and then returns have the control feedback from the satellite to the ground segment. So you can see that it's like small data coming, which are related to both of them. We cannot say who is the owner of this data. They have exchange and they have interfaces all the time. So I show, before I show you that model, and now we can see that we can put all this in that model. I show it here as heritage. This is heritage, but in the final model, it will not be heritage. We will populate model to the ontology we are provided. So why I use heritage here? Because this is the first discipline. We have only one discipline now creating with this approach. So we need more disciplines. So then we can show it in population. So it's like in test phase, actually. exactly the same. Solar array presented by two different perspective, which is like ground or external system, and our system of interest, which in this case is space system. So why I show you this photo from before is our CDF room. As you can see, I told that people are sitting around the table and working on that satellite or whatever. So you can see that how it can be useful here, because this kind of ontology, they go inside that MDAC hub that we have, and this real-time data exchange, it will facilitate this real-time data exchange and calculations. This is our goal, but we are still far from that. For example, for now, we are working in AIV, flight control, thermal, and different disciplines separately, but we are not yet able to put them in one data hub. So what we gain is like, okay, the whole thing is coming from our daily work and our daily problem we face during CDF studies, and then we saw based on the digitalization roadmap from ESA, we say that okay, the interoperability needs has been like increased. And they say that, okay, we need to do that because we are focusing on model-based system engineering. We are system engineering discipline, and we are moving from classic system engineering to the model-based system engineering. For the future, as we were thinking to do all disciplines and connect it to the core higher level ontology. Sorry. And something else I wanted to say is that based on what we did during this project is that if you just focus on one domain and you do not consider its exchange data, means that you do not consider engineering process in that modeling domain engineering, you will have problem in integrating different ontologies. We still have problem in technological aspect, how we are gonna integrate those ontologies, how we are automatically, of course, and how we can do the test, but we are continuing that. One more thing that is that we have this MBAC 2022. We have every year MBAC conference. This year will be in Toulouse with CNES and EBOS. And some part we are presenting the ontology works we are doing. And that would be so useful if we see some of you there. Thank you.
Thank you. Thank you. It's great that ontologies are going to space. Is there any question from the audience? And meanwhile, I check the system here. Is there any? Yeah.
Hello. Oh, thank you for the presentation. Actually, I read a lot of presentation about this ontology. So actually, I have some question about this ontology because my main major is also about the model-based systems engineering. So I think this ontology is, as you say, is very easy to readable, especially this, but the problem is that this one is a graphical database. So, graphical specification. So my question is that in the future, so how to integrate this graphical specification into the semantics specification? This is the first question. The second question is that I think just as you showed the mission model part, that model should be developed in the SysML model or UPDM or UAF, like some system modeling language. So my question is that when you design this ontology, in the future, how you can consider about the meta model part. So this is also another question, because when you integrate this ontology with other SysML or UML or maybe UPDM languages, so if you want to use the meta model to integrate, that means you must define the ontology from the meta model level. So yeah, so I'm very interested in this, your future trends, actually. Thank you.
Thank you. Okay, that's very good question because we already have that question. If you have some answer, it could be useful for us how we are going to integrate it. Because as I told, because ORM is good in verbalization, which facilitate this whole exchange with experts, but we don't have yet a solution to integrate them automatically. But from verbalization to the graph model, it's automatic. So we have both versions. It's not like we write the verbalization, we don't have the graph or the semantics. So we first extract semantics, and then we can we create the verbalization. So it's not separated. About this project, they are all in SysML. We have a SysML Camo collaborator. So we created our SysML profile, which I cannot that much present it here. Maybe in MBSC 2022, you will see some presentation from ISA SysML profile. ISA SysML profile is a space-specific SysML profile. So we create an ontology for that one. When I talk about item, for example, or when we go through the function, those SysML profile, they explain the main concept. So we refer to that, to those profile, prepared for profile. And then when we go through the project, which are different from the core system engineering, like, I don't know, solar array, items are detailed, we know how we create our product tree and function tree based on that SysML profile. No, it is connected. And we do this because we want to put the SysML or whatever in our MBC hub. So it's not going to replace SysML or whatever. It's going to connect all SysML in data hub. Hope I answered.
Okay, then maybe we can continue the discussion. We have a question from the web. Are the online, by Stefano Borgo, are the online models you mentioned, are the domain models you mentioned all built by the European Space Agency?
Yes.
Yes. Do you want to comment more, or it's okay?
Yes, that's better to explain more. The European Space Agency started to create this SMOSI project or space system ontology with different partners in European space aid companies. So this is mostly for now focusing on system engineering. So we have the first version, which is system engineering ontology. So, okay, maybe I need to explain a bit space system standardization, because space system standardization starts with that, okay, we have system engineering and we have disciplines. These system engineering standards are the core. So OSMOSI does not do anything different. They do modelization of that ECSS standard. So it is the core, it is there. We are in the review, we will be in the review of the first release soon. But as I explained, nothing is, how to say, applied. It's not yet in usage phase.
Okay, thank you. Is there any question from the audience? Yes.
Thank you. My question for you is because you talk about perspectives. So how perspectives are defined? I mean, it's based on the domain expert specialty, or it's based on the goal for the ontology? Because when I saw the eye, it is supposed to be a point of view or something like that.
Yes.
So it is based on domain expert then to define which perspective we have to take or to.
Yes.
to
In this one, here I explain one. I hope I have time. Here, when I explain that it is solar array, when I'm doing thermal modeling, the thermal is the discipline, my universe of discourse. So everything is defined based off thermal engineering needs. So I take thermal engineering requirement. When thermal engineering talks about that, what kind of solar array I will have, for sure he will talk about how it will be attached, how is mounting site, mounting properties. But mounting properties is not something that thermal engineering does. This is structure who does that. So how we reach from thermal to the structure, this is from based off that thermal viewpoint. But we need to do for all disciplines. So we will go then to this structure, and then we have the same stuff. We continue. But the one that we are modeling now, because we go discipline by discipline, the one that we are doing is our universe of discourse. So that one explain our main perspective. So it is defined in their standard, ACSS, and domain expert. These are my main inputs.
Any further questions for Ella? So I have a question. So so you mentioned that the technology is not still developed, or this is more at the research level, the conceptual level at the moment. So this is good. It's great. I was wondering whether you plan to use semantic web technologies, or if you see any advantage in a possible application of the semantic web.
Well, from the technology point, I don't know if we can go from ORM to any kind of technology. I know that there are some to do that for SQL, but we are struggling. So I'm not seeing any discussion about that yet, because I know that this is the software part that are doing that. They are open. They are open to any solution that they can integrate all ontologies.
Okay, great, thank you. Okay, then let's thank again Ella. And we move to the last paper of the session. You, Christina, step on the stage.